Our next speaker is Matej Hoffmann. He's presenting Blanket, Anonymizing Faces in Infant Video Recordings.
Okay, yeah, good afternoon again. So this is work in collaboration with like computer vision experts in our department. The first author is Ditmar Hadera. This was his bachelor thesis. So the motivation is the following. So we have a lot of videos like this one, where a baby is doing something. Typically the videos are rather short, like 5 to 10 minutes recordings often, and we would like to know what is she doing there. And so we need more than 5 minutes, most probably, right? Sometimes it's longitudinal, sometimes we have it every week, but still we really need much more to be able to say something. So for example, Philippe Rocha, you know, there's a quote from his paper, would say that at this age maybe the infants engage in exploration, or they are actively involved in investigating something, right? Now, how much data it takes for you to be able to claim that, right? So I think we need a lot of data. Actually, our attempt to do that with the existing data, Francesco Poli is going to present tomorrow, where we used hidden Markov models to see whether there is like a hidden state that is exploring the body and another state where the baby might be doing something else. So long recordings and dense sampling of development are needed for progress in developmental science. Karen Adolph, she's a big advocate of these videos and sharing videos and long videos, and so here are just some papers on that. And so these long recordings are hard to come by, and so if somebody has them, then we need to share them. But the bottleneck may be the privacy and the ethics concerns, right? Very often your IRB protocol doesn't allow that. And so this is where this work ties in. So we developed what we call Blanket. It's a tool for anonymizing faces in infant video recordings. So what you see on the top is the original picture, an image, a frame from the video of a baby, while the one below is the one where we swapped the face. So I will explain to you how that method works. So typical, you know, the diffusion models and other machine learning models, they are trained on adults. So infants are always like a special case where the things may work or not work. And they often distort facial features. So Blanket is baby face landmark preserving anonymization with key point detection consistency, and I'll explain to you what that means. So we want to de-identify, we want to change the identity, so we're swapping the face. We want to preserve like the downstream tasks like facial expression, gaze, pose. Pose is what we are most interested in, but also the others are relevant for other researchers, and such that there are no obvious artifacts. So, so we've got this pipeline. So here is the original video, and so from the first frame we generate a compatible identity face. Okay, you may have more of them generated. It's a generative model. You may choose. You may also tune what kind of face you would like to have, but you generate one face that is similar yet different. And then you have a video on the input, you want a video on the output, and you want a temporally consistent face swap. So that's the next thing that you need to take care of. So how it works is that you detect a face, then you detect the landmarks in the face, then there is a binary mask, so you mask the area you want to swap, and then you have that other identity face generated, and that you then plug in that frame. And then there is this extra piece of work to make it temporally consistent. So that's this temporally consistent face swap. So you want to avoid flickering, and you want basically to preserve the continuity between the frames. So here's how it works. So the top is the original video, and the bottom is after we applied this Blanket. So keep in mind we're only replacing the face, what has been masked, right? So it's kind of, you may have the feeling that it's the same thing because everything else is the same, right? So this is only really swapping the face. And yeah, this is for another baby. And yeah, we can then discuss whether this is enough or not. I'd be happy to discuss with you. We are aware that we might not be de-identifying it enough, right? And that's something that's like that's something that can be worked on. And so then we took one more network, which is called Deep Privacy. It's a popular anonymization tool, which is failing really miserably. It's not that we like took a tool that doesn't work. It's really a popular tool that is state of the art. But in this case, it really doesn't work. Okay, so these are our original images. This is Blanket. That's our method, and this is what this deep privacy tool would. So when you see it moving, it would be maybe even more scary. But okay, so that was the qualitative. The quantitative comparison is here. So you want to preserve the features. There is some automated tools that can, you can measure. There are some metrics how that is preserved. So there is the gender ratio, race, emotion. So so Blanket is doing quite well there, and then the correlation of landmarks, anonymized identifier. So yeah, I don't want to go into these technical details, but you can quantitatively measure the performance on these different criteria. And Blanket is doing definitely better than deep privacy. And yeah, so this is all right. All right. Yeah, I think that. Okay. So we want to also quantify the impact on the downstream tasks, so on pose estimation. So, alternative popular de-identification methods would be that you put a black rectangle over the face, and then you so this is the original image. Then you apply, say, VIT pose or some other human pose estimation algorithm to get this kind of skeleton with the key points. If you apply the same on this here, then it really the performance goes down quite a bit, which you see here. And this is for deep privacy applied and for Blanket. So you see that in this case, Blanket is really preserving very nicely the pose estimation, which is what we are very much concerned about. Presence of artifacts. So we conducted a user study. They filled questionnaires whether they guess the footage is original or artificially modified. And so for Blanket, they did recognize there was some flickering, some artifacts, so most of them did recognize that this was manipulated, but some of them were actually completely fooled that they thought it's original, while for deep privacy, obviously, everybody knew that this was manipulated. Here is the other scores, which is about the de-identification, where the red bars are deep privacy, so that's doing really well there. And ours is, they recognize it's changing the identity, but not so much, right? That's something that we might want to improve. And yeah, you have seen this already. Good, so conclusions. It's a fully automatic infant video anonymization tool. We experimentally compared with deep privacy, and we may want to, play with the de-identification to make it stronger on the face, but perhaps also on other features. For example, keeping the hair constant, is also a big part of the, at least your subjective kind of feeling of the identity. And handle missing detection, because if we don't detect the face, then we cannot swap it. And so, where does this fit in the in a bigger picture of our project? So these are these AI tools for developmental science. So this is one of them. The other tool was the retargeting you saw, or the pose estimation. So we're using these tools to process videos and other data from infants, and we do computational modeling, and then we do theorizing about body know-how development. And so there would be PhD positions open on these tools and the computational modeling, and I'm also looking for a postdoc to coordinate the theorizing and the empirical data with the infants. Thank you very much.
Thank you. Can you hear me? Yes. Thank you very much for the talk. I think it's a very interesting idea to try to anonymize these videos. But I also wonder what are the uses that you for this anonymized videos. I'm asking because for some research purposes. I think the videos might be, the changes in the facial expression might be a bit problematic. For example, what you showed, the modified faces look like of different age, much more alert, etc. So depending on what kind of research you want to do, I mean, if it's just for other purposes, but I just wonder, and also which criteria did you use to assess the, preservation of emotion, gender, etc., etc. So it's actually two questions. Thank you.
So we're swapping the face, right? So if you're specifically interested in the face, so the idea is to preserve also the emotions and to preserve also the gaze. But this is of course harder to do when you actually swap the face, but it's possible. When you're concerned about, for example, the rest of the body, which happens to be our main concern, then we are fine. So then you have these measures for how it preserves emotion, how it preserves the gaze. The diffusion model has some priors, obviously, that, for example, that the eyes are open. So if the baby, as you notice, has the eyes closed, it tries to kind of, open the eyes up. So yeah, there's things to play with. Yeah. And the main use should be really to be able to massively share that. So there's, platforms like DataBrary, but depending on what your IRB protocol allows, I think typically we're not allowed to share, put on the cloud videos of babies. While if we can say, to our review board, this is going to be anonymized, and then we get the approval and the informed consent, we might be able to do that, and that's going to actually help a lot.
First of all, thank you so much for the presentation. So I had two small questions. The first one is that have you considered using post-trained model with specifically optimized for baby faces? That's the first question.
We haven't done this kind of fine-tuning, not yet.
Okay, and the second question is, actually we're mentioning about whether it was, if the identity is changed enough, but I want to ask the reverse side of that question. So one of the main problems with the diffusion model is sometimes, especially in the copyright things, people say that this is my work, like this is my face, etc. So have you considered also checking whether the generated face actually belongs to a data point with a reverse privacy concern, because you're trying to anonymize the original face, but it might belong to another baby's face.
Yeah, that's a good point. Actually, some of these networks, they have some knobs that you can choose. I want this to be 40% Angela Merkel, and but I don't have an answer for that. No.
Thank you so much.
Thank you, Matej. Following a bit what Lola was saying, actually, I have the same impression that if you're looking for emotion, to preserve emotion and facial expression, there's a bit of change between the original and the blanket. Obviously, the privacy too is not working. It looks more like an Aphex Twin video clip generator than. But I'm wondering if using this kind of instruments might bring to some kind of, homologation of expression of emotion, like the system is trying to reproduce the same facial expression that it's in the original video, but smoothing it and something like that, so you might, lose a bit of heterogeneity into the into the different videos that then you have.
I think the people working on that in adults, they want to also preserve the emotion, so there's work on that, and we will have the reality gap to the babies that we will have to somehow take care of. I don't know more about that.
So I would like to invite the next speaker while we take another question. Up there.
Alicia. Yeah.
Thank you for the very nice talk. Matej, I was thinking of a possible experimental use of this tool, because you know that in cognitive neuroscience we have this whole developmental field in which we study how self-identity is built in the brain. But the problem is that we know always how to dissociate the identity from the sensory motor aspects by covering up the identity, but we never know how to dissociate in the other way. So we always can cover the hand and show just the kinematics and ask the subject if he can recognize the kinematics without the visual identity, but we can never take the identity and put it on somebody else's kinematics. So I think that I was gonna ask you if you think that this methodology can be exploited also for other body parts, and if you think that this could help to create this dissociation that we normally don't have in experimental paradigms.
All right, so you mean like swapping the hand, for example, to get putting an adult hand or another left hand or something. I mean, not this particular tool, but surely there would be a different kind of diffusion model that can do that. That's a good idea. I think that can be done. Yeah.
Thank you very much, Matej.